Greetings, Math 111. I am going to go through practice exam 4. So we're going to go through it fairly quickly because I don't want this video to be too long. These answers are all posted on Canvas, so you may want to pull that up while you go through this in case you can't see very well. All right, so number 1 says the definition of a severe storm is that an average peak wave height of 16.4 feet for waves hitting the shore. Suppose that a storm is in progress with a severe storm class rating. Let us say that if we want to set up a statistical test to see if the wave action, for example, the height, is dying down or getting worse. If you want to test the hypothesis that the storm is dying down, so mu, always define that, is the wave height. And of course, if the storm is dying down, the waves are getting smaller, right? So that number would be going down. So if I was going to do an alternative hypothesis, so H1 colon mu is less than 16.4 feet. And that means my p-value is on the left side. So this would be a left-tailed. So that is left-tailed. All right. Number 2, suppose the historical mean for a certain manufacturing processes is 58 pieces per hour. So that would be my null hypothesis. What's that? 58 pieces per hour. Suppose you are the area manager who wants to set up a statistical test to challenge the claim of 58 pieces per hour. What would you use for the null hypothesis? Well, we just read that out. That is the null hypothesis, is H naught colon mu equals 58 pieces per hour. Number 3, the price per earnings ratio, it is an important tool. And this is a very long explanation. And then at the end it says alpha is equal to 0.05. And the question is, what is the level of significance? That's my level of significance, that 0.05. Number 4, let x be a random variable representing the dividend yield of Australian bank stocks. We may assume that x has a normal distribution with sigma equal to 2.8%. Now, ding, 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 I just clued in that I'm going to be using z, right? Because if sigma is known, I will be using z, not t. A random sample of 27, so my n is equal to 27. 27 bank stocks has a sample of x bar, so my x bar is 8.83%. Do the data indicate that the dividend yield of all Australian bank stocks is higher than the historical mean of 7.3? So mu is 7.3%. And it says use an alpha of 0.01. What is the value of the test statistic? So that word test statistic is code for z or t. So my z value is 8.83 minus 7.3 over 2.8 divided by the square root of 27. Again, don't forget you need parentheses when you put it in your calculator. So that is 2.84, okay? And again, that formula I just used is z equals x bar minus mu over sigma divided by the square root of n. Okay. Let me do a little erasing up here. All right, page 2. Number 5, let X be a random variable that represents the pH of arterial plasma. So pH, so X is the pH of arterial plasma. Okay. For healthy adults, the mean of the X distribution, mu equals 7.4. A new drug for arthritis has been developed. However, it's thought that this drug may change the blood pH. A random sample of 31 patients, so N equals 31, with arthritis took the drug for 3 months. Blood tests showed that with X bar equal to 8.1 and a standard deviation, S, a sample standard deviation, okay, so that's important. That tells me I'm going to use T, not Z. And that alpha is 0.05 to test the claim that the drug has changed either way, ding ding, two-tailed then, right? So I have things on both ends. Has changed either way let's see, either way the mean pH of the blood level. They want the p-value. So all I have to do is do the p-value. So I'm going to use, first I have to find t. So t equals X bar minus mu over S divided by the square root of n. So I have 8.1 minus 7.4 over 1.9 divided by the square root of 31. Okay. And remember, this n is n, not n minus 1. And I find that that value is 2.051. I go to my t-chart, magic t-chart here. Let's see where it is. I go to my t-chart and I do, let's see, if n is 31, then my degrees of freedom is 30. So I go down to the 30 row and I go across until I find a value that this falls in between two values where this is on the t-chart. So again, that's a t-value. And I run my fingers up. This is two-tailed, so I have to go to the right row. And I see that my p-value is 0.050, which is greater than p-value, which is greater than 0.020, okay? You could write it this way. Also, you could flip those values around if that made more sense to you. So in this question, you were just doing the p-value. You don't have to actually tell us if you accept or reject. So I didn't need that 0.05, but I always write all my information down. All right, number 6. So number 6 says, when using the student's t distribution to test mu, what do you do? What do you use for degrees of freedom if the sample size is 31? So degrees of freedom is n minus 1. So if n is 31 minus 1, then I use 30 as my degrees of freedom. A random sample of, number 7, a random sample of 60 binomial trials, so n is 60, yields 18 successes, so that's R is 18. Test the claim that the population proportion of success exceeds 18%. So that's my little p. So that would be a historical, and I'm going to turn it into a decimal because that's a little bit easier to follow. So it says 18%, I'm going to use 0.18. Use a level of significance of 0.01. What is the value of the test statistic? So first I need to do p hat. P hat is R over n. So that's 18 over 60, which gives me a nice round 0.30. My z score is p hat. Again, we use z when we're using little p, okay? So use z, p hat minus p over the square root of p times q over n. So 0.030 minus 0.018 is the square root of 0.18 times 0.82 over 60, which gives me a 2.42. That's what we're looking for, is the value of the test statistic. All right. Drew myself some lines so I wouldn't get out of the view of the camera, so hopefully I stay in it. Okay, oh, that was number 7 there. We'll just leave that. All right, so number 8. A professional employee in a large corporation receives an average of mu equal to 41 emails per day. Most of these emails are from other employees in the company. Because of the large number of emails, employees find themselves distracted and are unable to concentrate when they return to their task. In an effort to reduce distraction caused by such interruption, one company established a priority list that all employees were to use before sending an email. Probably a good idea, huh? 1 month after the new priority list was put into place, a random sample of 33 employees showed that they were receiving an average of X bar, this would be a sample, of 34.1 emails per day. The computer server through which these emails are routed showed that sigma equals 17.2. Again, I think this is a little weird that you would know sigma when you didn't know mu, but sometimes you do. We're going to use 0.05 for alpha for our level of significance. Remember, alpha, level of significance, is the same thing. To test the claim that there has been a change either way, okay, so that means it's two-tailed. Two-tailed. And I know I'm using z, right? So I'm going to have a z and a negative z. I'm going to have z, and it wants us to find or estimate the p-value. And this is one of those where we're going to have to multiply times 2, so make sure you stay on top of this one. My z-score is x bar minus mu over sigma divided by the square root of n. So I have 34.1 minus 41 over 17.2 divided by the square root of 33. So I get a negative 2.304. Again, that's a z value. The probability that z is less than negative 2.304. And of course, I always encourage you to draw little diagrams like this. So this z value is 2.304. You look that up on your chart because we look up things to the left. We find that that value is 0.0214. Whoops. Let me look up the actual value because I just looked up, I wrote down what it was already multiplied. So let me look up the value. Negative 2.3, and that would be negative 2.30, is 0.0107. And then when I multiply both sides by 2, right? Oh, I did have that written down. When I multiply that times 2, I find that my p-value is 0.0214. That's the answer we're looking for. Again, how did I know to multiply times 2? It said it was two-tailed. I found a z-value. I know that that describes one tail. This area and this area, because these are symmetric. Remember way back at the beginning of chapter 7, we said these two things were symmetric. So I know I just double it. I I can guarantee there'll be at least one of those on the exam. 9. 9 says, consider a binomial experiment with 850 trials and 452 successes. Find the proportion P, so we want P hat, which is R over N, which is 452 over 850, which is 0.53. There's my answer. That one was pretty short. Benford's law claims that the numbers chosen from very large data files tend to have a 1 as the first non-zero digit disproportionately often. This is actually a true law. It's kind of interesting, like a numerical law. In fact, research has shown that if you randomly draw a number from a very large data file, the probability of getting a number 1 as the leading digit is 0.301. Suppose you're an auditor for a very large corporation. The revenue report involves millions of numbers in a large computer file. Let's say you took a random sample of N equals to 303 and R equals 77 of the entries, and had a first non-digit of 1. Let P represent the population proportion of all numbers. Test the claim that P, like real P, is 0.301, is less than this. Okay, so this is a left tail. So this is left tail. And because this is a proportion, I'm going to use a Z value. So you always want to stop and ask yourself that. And let's see what else we know. R equals 77, we got that. Oh, alpha equals 0.05. And it says the p-value of the data is, so it gives us that. The p-value is equal to 0.0375. Are the data statistically significant at the significance level? So I always want to go p-value, alpha. If alpha is, what is that, 0.05, and my p-value is 0.0375, I see that 0.05 is bigger, so p-value is less than alpha. It's statistically significant, and I reject the null hypothesis. So that's answer A on this practice exam. You will reject the null hypothesis because the data are statistically significant, right? That means something significant has changed. So yes, it did make a difference. All right, I'm doing pretty good here. Actually, I am gonna break this video. So those were questions 1 through 10. I'm gonna stop and start up again.